Hello, this is Professor Simpson with Section 3 of Chapter 6 on molarity. As always, you see I have listed the learning objectives for this section here, so take a second please to jot these down. But you'll see here we're going to talk about the properties of solutions. We're going to calculate one type of concentration, which is molarity, and then we're going to perform some dilution calculations in this section. So just to get us started here, you may remember we used the term solution earlier in the year when we were talking about different types of matter and how we classify matter in that the categories of substance and mixtures, and then with regards to mixtures, we talked about heterogeneous versus homogeneous mixture. So at that point in time, we referred to a homogeneous mixture also as a solution, and that's due to its uniform composition throughout. Now, before we get into the components and properties of a solution, I want to give you just a quick definition of concentration here. And I'm just going to give you a basic kind of vague definition, which is relative amounts of a given solution component. The reason why this definition here is a bit vague is because although in this particular section we're going to look at molarity, you'll see in the last section in chapter 6 that there are different ways we can relate the components of a solution together that would also be considered different types of concentrations. So on that note, the two components in a solution are the solvent and the solute. These are terms you may be familiar with. Typically, the solvent has a greater amount than the other components, and the solute is the smaller. You can also think of it in terms of what's happening with these two components. So the solvent is the thing doing the dissolving, and the solute is what's being dissolved. With regards to an aqueous solution would be one in which the solvent is water. And you may recall that water is the universal solvent. So as I stated a second ago, we basically are going to be considering three different things here. We're going to be looking at the amount of solute, solvent, or solutions, and these are going to be the basis of the different types of concentrations that we'll calculate. The relationship between, say, the solute and the solvent, or the relationship between the solute and the total solution. So this will be the setup that we use here as we move along and talk about the different relationships here that could go on and how we relate those in the various components back to that definition I gave you for concentration, relative amount of a given solution component. So we'll talk about these aspects of a solution and the relationships as we do some concentration calculations. Now, as I said, in this section, we're going to start with molarity. Okay, so molarity is moles of solute per a given liters of solution. So you can see here the definition sets up in the formula for the calculation for molarity. So moles of solute per liters of solution is the definition of molarity. Now, as you can see by this formula I have here, this equation, this is a pretty straightforward calculation. If you're given solute, you're given solution, divide, you get your molarity, and vice versa. So if given any two components here, the expectation is you'd be able to manipulate this equation to solve for the third. I just do want to point out a couple things here, and I've got a couple example problems that I'm not going to work here, but I just want to point out a couple things that you may run into when dealing with molarity problems. So first of all, similar to when we worked with density earlier in the year, this is an important unit for us because molarity, as you can see here, is also moles per liter. So similar to when we worked with density, the ability to go from a mass unit to a volume unit or vice versa, molarities allow us to convert back and forth between moles and liters. And as we know, if we're working with moles, then we know how to get to and from moles with regards to grams and particles and so forth. So you can see that this can become a pretty important conversion factor for us based on those units. Now, as I look at these two problems here, like I said, I just want to point out a couple things. So, as always, what's the problem asking for? What is the molarity? So I'm thinking to myself, okay, well, I know molarity is moles of solute over liters of solution. So all I need is those two pieces of information, and it's back to plug and chug here. Now, what you'll see, though, is when I go back and look at the problem and try to pull that data out to plug and chug, that I'm not given either moles or liters in this particular example. So you're going to have to do some work often either before or after with regards to converting units. And so that's what I run into here. So now I can think about what the components are to help me know which to convert, which number to convert to what units. Obviously not quite as difficult here in molarity, but you'll see some challenges along those lines in section 4. So it's pretty clear here that the 63 grams are my solute. So I'm going to have to, do a conversion where I convert grams to moles using the formula mass for NaCl. And then I'll have moles that would allow me to plug it into my molarity equation. And then 650 milliliters, right? So I need that to be in liters. So again, I can do a quick metric conversion here where I'm converting milliliters to liters. So this is I point this out just because it's pretty common to have to do some conversions when you're dealing with molarity problems. They're not going to always just be real straightforward and give you moles and give you liters, because often that's not how they're measured. That's not how the data is collected in a lab setting. This next problem, as I stated at the beginning, so the equation for molarity is pretty straightforward. As I said, molarity equals moles over liters. So the idea here is that the expectation here is that if given any two of these, you should be able to solve for the third. So in this particular problem, they're actually asking for grams of NaCl, which is my solute, and they have given me my volume and the concentration, my molarity, right? So I'm in a situation where I know the molarity again, that's moles per liter. And I know, obviously, with a quick conversion there, I know liters. So I'm left to solve for moles. Now, once I do this and have my once I manipulate this equation, this molarity equation, and have my answer in moles, now I'm back again to a conversion where I'm going moles to grams, and again using the formula mass for NaCl because that's the solute here. Okay, so I just wanted to highlight these two examples here because I think they're good examples of it's not always going to just be pull numbers out of the problem, plug and chug. You always have to, as we talked all year, you always have to be mindful of your unit. Do your unit analysis to make sure that units are canceling or making sense as you work your way through the problem. So just be aware of that as you get into some of your molarity practice problems. Okay, so the last topic to cover in section 3 here is that of dilution. This is actually something that happens quite a bit behind the scenes where we take concentrated solutions and dilute them to different concentrations to use in some of the laboratory experiments. So you see the definition here and the formula for completing a dilution, and it's pretty straightforward. It's the concentration and the volume that you start with, so your initial equals the concentration and the volume after the dilution. So you see that I'm just using C here for concentration, but most commonly we would be using molarities. So it would be the molarity times the volume, the initial volume equals the final molarity times the final volume. So if I need to dilute something to dilute a solution to some new concentration here, some new molarity, you can see how the relationship's gonna play out here. So you can see here I've put in a simple dilution problem just to walk through it with you. What volume of a 1.59 molar KOH is required to prepare 5 liters of a 0.1 molar, right? So here is our diluted concentration and the amount of it we need. So that's going to be our M2 and our V2. So at the end of the day, I'm going to need a concentration of 0.1 molar, and we're going to need 5 liters of it. Okay, so in order to dilute it, I have to figure out how much do I need, what volume of it do I need of the concentrated 1.59 molar that I start with. All right, so simple math here, and we get the volume of that concentrated we need, and then the actual application of that is then we would take that amount of the 1.59 molar and we would add the water to get to the total 5 liters. And then we would end up with a new concentration of 0.100 molar. Now, while that last example problem may be the most common application of how we utilize this relationship, it doesn't have to be the only way that the only question we ask here. So you can see in this second problem I've provided what volume of 0.12 molar HBr can be prepared from 11 milliliters of 0.45 molar HBr. So as always, you just have to think about what's the problem asking for and what information is it given. So we're asking for volume again, but in this case, what they have given me is the initial concentration before the dilution. You can see here that this value of molarity is greater than this value. So this is my concentrated value over here, or my M1 or C1, however we want to call it. And then here is my then V1, because you can see those two values go together. So then that would mean here's the new concentration I'm trying to get, and then we're looking for volume. All right, how much of that can be prepared? So again, the formula doesn't change. The equation here, sorry, doesn't change. And we're back into a plug and chug situation. And we're good with our units here because they've, even though initially listed it as 11 milliliters, they've actually given me the liter value. So plug and chug, and I can solve there for my V2. And so you see here a little different setup as far as what the question was asking for. But again, I'm pulling the data out of the problem by just kind of breaking it down step by step. What is this problem asking for, and what data has this problem given me? So on initial read, you may look at these two and say, well, they're both asking for volume. That's great, but then the second part of that, like what is the problem giving me? You can see I've been given very different data in both examples. Okay, that wraps up section 3 of chapter 6. Hopefully I've emphasized throughout here that the new equations we've given you here are pretty straightforward as far as solving in the plug and chug. Just as always, got to be careful of our units and do our unit analysis as we are pulling the data out of the problem and plugging it into our equations. Okay, in the last section of chapter 6, we're going to talk about some different types of concentration calculations.